No, give me this chance. No. If I gotta do this now.
Children. Please.
No. No, sir. I don't know. Let me get one of them chairs because I'm gonna have to sit down while I'm doing. Thank you.
Now, guys, here is your problem to solve. Now, this is, again, this would be considered on a scale of 1 to 10. This is probably about maybe a 4.3, 4.5, maybe a 5 in terms of being complex. So you've got to read this thing very carefully. It says coke is an impure form of carbon that is often used in the production of oxides or the production of metals from their oxides. If a sample of coke is only 95% carbon, okay, what mass of coke is needed to react completely with 1 kilogram of copper 2 oxide in this chemical reaction? So I'm not looking for how much carbon is required, I'm looking for how much coke is required. Now you're going to have to solve for carbon first because carbon is the only thing in my equation. You're going to have to think about this a bit, okay? JJ here is going to solve this for us very simply because he knows exactly what we're doing here, which is why he didn't fall asleep, or he was falling asleep, because this was just so, to him it was just like, oh my God, do I got to do this again? So, what I would suggest that you do is why don't you get a sheet of paper out and copy it all down so when you come up here to explain it to everyone, you'll be able to do it in a very concise manner. Thank you. Go. We're there?
That's the comma.
Well, comma, period, whatever you want to call it.
It's not English, it's period.
Okay, and then make that a capital W there.
Yay.
But that's a period, that's not.
Well,
It
hey.
says French, it's not English, it doesn't matter. It's not English.
There you go. Now you got a comma. Too bad the comma's not around. But, who cares?
I got my comma in too, but I wanted you to use period.
Now you guys better discuss and see how this thing is actually done.
So wait, okay, so we have to do it, you want us not doing it?
Well, you guys are going to attempt it, and what you're going to do is, my guess, is that as Juwan is going up here and trying to do the work, you may have to actually tell him what to do.
Okay, well, let me actually read this.
You have no faith in me?
I do have a lot of things. I really do. So now you're just going to quit, right? You don't have faith in
No,
me?
because if you don't have no faith in me, I'm going to try to prove you wrong.
Okay, good. Then prove me wrong.
If you have this to react to
Yes, it means 100%.
Gotcha.
So when it says completely, that means that it's all got to go away.
Is the first sentence irrelevant?
Yeah, for the most part, it's irrelevant.
What's relevant?
The first sentence.
It's irrelevant, I mean, yeah.
But you got to have some background information.
So what, is this true?
Okay. Yeah, this is absolutely true, by the way. Is this what? No, this is not Coke the drink.
It's cold.
It's you know what?
Oh, are you talking about the snippy Coke?
This Coke is the stuff that they use at steel mills. It is pure carbon.
But it says
Okay.
impure.
But Coke is an impure form of carbon, which is what they use at steel plants. So what they're doing here is this is a legitimate problem with numbers that are exact. Coke is about 95% carbon. Okay? Carbon is what makes the steel stronger.
I need you.
Okay?
I don't know what to do before to start. I need you.
No, and all I'm going to say is I would like you to try this on your own.
There's no bauxite. I don't know what to do.
I'm going to tell you that you guys have to be able to think.
You just gave me one problem as an example. I don't know where to go from here. There's no bauxite in here. There should be a bauxite. So there's two O's. So then you need two C's. So then you need two. So it'll be two, right? Two. No, it's two. That's right. Wait. Yeah, two. No. Yeah.
You want to run this up?
No, you're wrong.
There's no bottom side. So let's sit. Can I mute it? I think better.
Not this time. I want your mind 100% on this. Not split it 95%
But
efficiency.
that's when I do better. I am working. So we have to break the 1 kilogram in grams first. Let me do that first. Okay. So I got 1 kilogram.
What you gotta understand here, that the only thing you know for certain is that you have 1 kilogram of copper 2 oxide, which means
So then
I know
what is
everything
coke?
about this compound.
Yep.
Coke is the stuff right here.
But no, what is it in here? What is coke? What is coke? Is coke like the bauxite?
Please understand the following. Listen to what it says. What is coke a form of? Carbon. Can you tell me where in the chemical equation carbon is?
Right there, let's see.
Good. So that's the coke they're talking about.
Yeah, I was trying to figure out where.
That's the coke.
So it's not bauxite. It's not bauxite.
Wait, what?
I wrote this down.
No, that's exactly. Well, yeah, Susan knows fine. Because this is a coke. Yes.
So this would have to be equal to.
Because I'm going to tell you right now that the only thing I know is I have 1 kilogram of copper 2 oxide. I don't have 1 kilogram of coke. I have 1 kilogram of copper. I have 1 kilogram of this stuff.
So you go from
Not right now it's not. What did, because I was giving you something different. Okay? Distillers basically means that in 100 grams of coke, there's only 95 grams of carbon. That's still, but I know nothing about carbon right now.
Yeah, like
Write out the whole page. And then that means I have to wait for 10 minutes, right? To figure out.
Oh, there you go. That's what you're going to start with.
Let's go. Oh,
I just need to know.
If I go
if I had
to
to- if I go almost at the end. So that's
All you do is like.
So that would be a good start.
No.
Okay.
Kyoko was repeating the
Of what?
Be careful as to what you think you have. In this problem, I only give you one thing, and that is how much copper 2 oxide I have, and that's it. I don't tell you how much coke I have. I don't tell you how much carbon I have. I tell you how much copper 2 oxide I have. That's the first part of stoichiometry. And what are you going to try to find? How much carbon? But carbon is coke or part of coke. So why don't you try to figure out how much carbon you're going to need first?
So then what's the point of using coke in the problem? Like we just.
Just, no, because that isn't what I'm asking. I'm not asking for how much carbon is going to be required. I'm asking how much coke is going to be required.
Coke is carbon. You said coke
Hey,
is
Ted,
carbon.
think about that a second. Think. Right idea, but you didn't say it correctly. That's important. It is the way you ask yourself the question.
I give up.
Wait, you said, because Coke is not Coke is 95% of carbon, but Coke also has something else in it.
Yeah, Coke is, but all I'm concerned about is how much Coke we're in. That has nothing to do with this.
Like, I just took 95%.
So wait, so of course you're supposed to change into grams. From
Say it again?
1 kilogram into grams,
Okay, that's good.
which I changed that.
Good. So now you know what?
I know that there's 1,000 grams of copper to oxide.
Perfect. So what, now that you know how much copper to oxide you have, what's the next step? What are you going to try to solve for?
No,
It don't make.
What are we looking for? Okay, there you go. So where are you going to go? Where do you see carbon?
Right here.
Well, use that one.
Wait, so right now,
Because you're looking for your carbon.
Because I showed you, it said 1,000 grams of oxide.
So after you find out how many carbon it is, just find 95% of that.
And then you'd be wrong.
So then you'd be wrong?
Oh, you find and you find 5%.
Why do you go here?
Why are you trying to see this?
What is Coke formula?
Why did you tell her to start with 1 kilogram of CO2?
I didn't tell start with 1 kilogram. No, I didn't. I thought you said CuO.
You started with 1 kilogram of copper to oxide. So I was wondering, why did you start?
It's 1,000 kilograms of Cu2O is where you start.
C2O.
That's
Yes,
all,
it is.
the only thing you know is you have 1,000 grams of copper dioxide. That's all. I don't want to hit you over the head just yet, but you'd be close. If you did it your way, your answer would be wrong. You've got the right idea, but you got to think about what you just said. Okay? And how you came up with 95% of that number. Write down
It's not like the other
the
part.
proportion. Write down the proportion.
In both.
Write down what the percentage is and what you have, and make sure you keep the units in the right place. That's the important part. Okay? Except, no. No. Because see, this is 95%. So it has nothing to do with this number here. Because that's 1 kilogram of copper dioxide. So this number has nothing to do with that number. So all I know is I've got 1,000 grams of copper. What I want to know is how many grams of. Yes, I did. I'm a shocking person. Okay, go. So far, you're halfway there.
I'm 50% there, guys. Then I'll be 95%.
Look, what it says here, you've got 1,000 kilograms, 1 kilogram of copper dioxide. It doesn't say you got 1,000 grams of copper, of carbon. It doesn't say that at all. It says you got 1,000 grams of copper oxide. 1,000 grams of copper to oxide. There's no 2. It's just CuO. And what are you solving for? Okay, what is Coke? Where do you find Coke in this chemical equation? Good. What of Coke can you find in the chemical equation? What is Coke made of? Okay, so guess what you will be solving for? Because carbon is part of Coke.
But you're trying to find what's cold.
Correct. So you can't do it directly. There's no way to go, there's no Coke in this equation. But there is carbon in the equation, which is basically a part of Coke. So if I can get this, I can then figure out how much Coke I'm going to need. But I gotta find that carbon first. Here's your first step.
I don't think no. Felicia, stop running.
Well, actually, this section. Because the way I would do it is I would go 5. Each of those sections. Yeah, you just cross multiply, which is what, no, yeah. Yeah, so that's.
Wait, right here, 79.479.
Okay, now here's the thing you need to know. Is what you're finding out is how much carbon is present. Now, if you think about it, you think about it this way. This number here is 75% of what number? Because the amount of Coke is always have to be bigger because 100 grams of Coke only has 95 grams of copper or carbon. Yes? So basically it says that no, it's 95% carbon. So that means so if I have 95 grams of carbon, I will have 100 grams of Coke. Okay? Well, if I only have 75.4 grams of carbon, how many grams of Coke are you going to need? That number has to be bigger. And it is because it comes out to be this number, not this number. Yeah. Just look at the paper. Yeah.
I was thinking about factors.
Actually, you would add 5%. So you would take that number here plus the 5%, and that would be how much Coke you have.
Okay, what is the carbon?
Well, no, we found the carbon.
So we're looking.
I'm looking for Coke.
So we have to add.
Yeah.
Oh,
Yeah.
So this is not right.
Well, no. This is the right answer. Okay. You don't have to do anything. That's it. That's the answer. Because that is giving you this much carbon and X amount of 5% garbage. So that's what it is. Yeah, it's the only thing is because you really screwed this one up because these things are reversed because that was so no way. Yeah, that's right stuff. Okay, good. Good. Let me see. No, you're so close though. You're almost crazy here. I want you to notice something here. That you have grams carbon up here. I'll tell you right now that's right. Yes. That's why I said when you do, you gotta be really careful with the units and the proportion. Whatever's up top over here. Right, that's why you gotta be careful about those units. Units are so important because in a proportion, whatever unit you have here, you have to find over here. Whatever unit find here, you gotta find down here. And if you do that, and you see when I went and I started doing that thing with you, what unit, and the person you said, ooh, I got, that's all I need. this isn't the way to copper oxide, or copper to oxide. Yeah, copper is 63.546, and oxygen is 50.9994. You use carbon, it's copper. So that's, everyone does that, so that's why when I look at it, I go, okay, forget the carbon stuff.
The movie they were in.
So why was,
That's the best thing.
Okay, actually, we came up with this figure. We came up with 75.4 grams, right?
It would have been on the same point.
So, I want you to think about what you just said, right? You have 70, it's 75? Okay, assuming that you did all your math work right here. I don't know what number that is, 79.4. 63, yeah, it could be. All right, so anyway, you're saying that you've got 75.4 grams of carbon, right? I don't pay attention to what it says. It says that Coke is 95% carbon. That means an average of 95 grams of carbon, there's 100 grams of Coke. So, if I have 74.4 grams of carbon,
Like, I literally have to write through that so that I can know, like, the leading page.
and so you're going to run a proportion.
you have to edit out some parts.
It would be like an
I have that out anyway.
some parts where it's like, I'm marked out all of
No. 143? No.
What's that?
What is that?
Did you balance equation here? Did you balance that equation?
That's the part that I finished.
Did you balance this with the 2 here?
It's called shiny.
Here?
It's a Korean.
One there. And
to the
so,
camera.
when I take a look here.
안녕하세요.
Relationship here.
안녕하세요, 여러분.
Two down here.
I didn't
One up there. Well, all I'm saying is, when you do this math work, when you do this whole thing here, 1 times 1,000 times 12, divided by this number, divided by this number. Do that math work and tell me what it is. No, you don't. You can't. No. Nope. Can't. No. Hey guys. Boy, this is a 5. What happens when I give you a 6 or a 7?
Well, we figured it out though.
Well, you did, and that's good. But the idea here is, you know, some people, they're not using
Can you give us another one?
what, yeah, tons of them. Now, since JJ,
I had a consultation error.
okay, cannot seem to do his math work right, let's see if we can solve this problem. So what I'm going to do here is say the following. It says I have 1 kg of copper 2 oxide. What I want to know is how many grams of carbon would be required to react with this. So I am trying to figure out grams of carbon. I can't find grams of Coke because Coke is an impure problem and I know nothing about it. Guys, Bianca, pay attention. You're not writing anything down, so this is where we run into a small problem, is if you pay attention, it will make sense. Now, if that's all I'm going to do, okay, 1 kilogram of copper 2 oxide. I know this, that for every 1 kilogram of copper 2 oxide, it's 1,000 grams of copper 2 oxide. I know that for every 1 mole of copper 2 oxide, it's, what's the mass of copper 2 oxide?
79.5454.
Okay, 54 grams of copper 2 oxide. And I know, according to the equation, for every 2 moles of copper 2 oxide, there's 1 mole of carbon. And I know that 1 mole of carbon weighs 12.011 grams of carbon. Now, what this is going to tell me is exactly how many grams of carbon would be required to do this experiment. Which in this case, 49, okay, we'll just leave it at that. Grams of carbon. Now, I don't want to know carbon though. I want to know coke. Well, this is telling me how many grams of carbon would be required to run this experiment. I know this, that coke, there are 95 grams of carbon in every 100 grams of coke. If I had 75.49 grams of carbon, how many grams of coke are you going to need to have that much carbon?
79.6.
And it's 79.46 grams of coke.
Calculation.
And there it is. Now, the thing you have to remember, this is the hard part. Everyone went back and tried to take, the first thing that they said, oh, I just take 95% of that number. No. Okay? Because you've got to understand what you just got. Which is why when you write a percentage, you make sure you write down all the units of it. A percentage, 95 grams of carbon over this number. I would ask myself, this number here is 95% of what number? Because the coke has to be a bigger number. Because coke has got to be larger, mass-wise, than the carbon that it's made up of. Yeah, it's got to be 5% larger. Or you could have just taken 5% of this number, and then just added it, and you would have come up with 79.46. I do it strict. If you do it by proportions, I meant you're going to be perfect. Okay? China, when she came up, she had these two reversed, which is what most people do. And all I said to her was, look at where the units are. Grams of carbon go up here, and all she goes, oh, that's got to be reversed. Okay? That's what you got to remember. That's the hard part. Okay. Her name is not China, it's Europe. Okay.
Close relation.
No, that's in a different class. All right, guys. I'm going to hate to do this to you, but I'm going to give it a shot. Here is your homework for tonight. And what I'm going to do is I'm going to pick maybe...
Is it just one problem?
Well, no, I have 3 down here. I'm going to give you, technically there's a lot more.
Okay.
Page 127. I'm going to give you 4 problems to do tonight. I want you to do problem number 89, 90, 91, and 92.
Why did you just say 89 and 92?
We have so much fun.
Because it's more, we have more anxiety when we're like,
Now, do me a favor. Read question 89.
It's what we just did.
Coke is an impure form of carbon that is often.
Yeah, but take a look at the problem.
It's a different problem.
It's different numbers.
It says 1 ton. It don't say kilogram. So when you have to change it over, you gotta convert.
You're going to have to convert tons into grams, or tons into pounds, and pounds into grams. I will tell you this, guys. Here's something you need to know.
What's your conversion thing?
It's so big. Why is it so big?
Ew.
Shut up.
Your friend.
Hey.
You know that?
Now you know some more.
At one time, it goes to 2,000.
This is the bridge for pounds and grams. Okay? There are about 454 grams in a pound.
No. I just did it the other way.
The proper way.
The proper way, and I got 909.
Oh my God, Felicia.
90.
Bye,
But
Felicia.
I just did it your way, and I
Bye,
got
Felicia.
90. I got 908,000. That's a big number to take
I'm going to
away.
tell you right now.
You should kick out.
Isn't it
She
supposed to
argued
be decimal
with
like
you.
that?
Yeah, actually there is. I think it's 5-3 or something like that.
That's a
It's
big
5:30.
Does it matter?
No. No. Guys, there's your work. Do it.
I'm gonna go to the conversion thing on here.
Yes.
It's about the
Let's use the conversion chart.
examining.
Un momento, por favor.